For a lot of us, getting clean, fresh water is as simple as turning on a tap. It's just there. But for a huge and growing part of the world, that's an absolute luxury. Today, we're going to look at two incredible new technologies that could totally change the game. One gets fresh water from the sea with the push of a button, and the other, get this, pulls it straight from thin air.
And that really gets to the heart of it, right? This statement is so important because it reminds us that finding new solutions isn't just some abstract tech problem. It's a deeply, deeply human one. Access to water affects literally everything for everyone on the planet.
So let's just take a second to really understand the scale of what we're talking about. It's easy to hear a water crisis and think of some faraway place, but from the American Southwest to, well, everywhere, the numbers are pretty sobering.
I mean, just let that number sink in. 785 million people. That's more than double the entire population of the United States. It's a completely staggering number of human beings who can't reliably get their hands on the one thing they need to survive.
And look, this isn't some far-off, distant future problem. We're talking about 2025. That's basically tomorrow. By then, half of every single person on Earth will be living in a place where finding enough water is a constant stress. Half. And this, right here, is the kicker. This is the fundamental paradox. We live on this beautiful blue marble, a planet that's covered in water, but this tiny, minuscule fraction is all we can actually use. The rest, it's either salt water in the oceans or it's locked up tight in glaciers and ice caps.
Okay, so if most of the water is salt water, the obvious question is, why don't we just, take the salt out? Well, we do. It's a process called desalination, and it's our main tool for fighting this problem on a large scale. But as you're about to see, it is far from a perfect solution.
So the basic idea is simple enough, and we've actually known how to do this for a long, long time. The technology exists to tap into that massive 97% of the world's water. But it's the how that gets really, really tricky and complicated. And here are those complications, laid bare. On the one hand, yeah, you get a huge amount of fresh water. Awesome. But then you look at the cons column, and yikes, it takes an absolutely insane amount of energy, which makes it super expensive. The high-pressure systems are always getting clogged. And maybe worst of all, you're left with this toxic, hyper-salty gunk called brine that gets dumped back in the ocean and wreaks havoc on marine life. It's a brute force approach, and it comes with some serious baggage. Okay, but now this is where the story pivots. This is where it gets really, really cool. A couple of brilliant teams have come along and decided to completely reinvent the process, moving away from that brute force model.
I mean, seriously, how amazing does that sound? It's straight out of science fiction. But these aren't just ideas on a whiteboard. They are actual working prototypes that have the potential to change everything. So let's break them down.
All right, so first up, the MIT device. Instead of the old school way of, ramming water through a superfine filter, this thing uses an electric field. The best way to think about it is like having electric bumpers in a bowling lane for salt and bacteria. They just get zapped and pushed to the side, while the pure, clean water flows right down the middle. No physical filters, no high pressure. It's just elegant.
Now, for the second breakthrough, and this one is an absolute game changer from UT Austin. It's a special hydrogel, and you're not going to believe what it's made from. Basically, plant fibers and a common food thickener. You leave this gel out, and it literally soaks up moisture from the air like a sponge. Then, when the sun warms it up, it releases that moisture as pure, clean, drinkable water. And the craziest part? It uses zero electricity. None. It just works, even in the middle of a desert.
So you see, these two aren't rivals. They're more like teammates, solving different parts of the same puzzle. The MIT device is a superstar for coastal towns or disaster relief zones where you have seawater and a little bit of power, maybe from a solar panel. The UT Austin gel? That's your hero for dry inland areas, places that are completely off the grid. They each serve a crucial different purpose.
So we've got these two amazing sounding technologies. It's really easy to get swept up in the excitement. But we've got to be realistic, right? We have to pump the brakes for a second and ask the big question. Are they truly game changers, or is this all just hype?
You're probably thinking it, I'm thinking it. It's the question you have to ask with any big breakthrough. Is this for real, or are we just getting carried away by some exciting headlines? Let's look at the actual reality of what these things can do right now.
Well, here's the really good news. This isn't just theory or a lab experiment. The MIT team, they packed up their device, which is about the size of a suitcase, by the way,
drove it down to a beach in Boston, stuck a hose in the ocean, and within about half an hour, they were drinking a cup of fresh water that was actually cleaner than the WHO standards require. It works. So, let's talk numbers. What can these things actually do? The MIT device kicks out about 0.3 liters an hour. Now the UT gel? A single kilogram of this stuff can pull over 6 liters of water a day from the air, even when it's not very humid. On a good day, it can double that to 13 liters. Now, these aren't numbers that are going to supply a city, but for one person or for a family, that's life-changing.
But of course, it can't all be perfect. There's always a but, right? No new technology is a silver bullet, and there are still some pretty big hurdles and unanswered questions before you'll see these everywhere. And there are some big ones. For the MIT gadget, even though it's super efficient, it still produces that salty brine. So what's the plan for that? And can it filter out things like industrial chemicals? We don't know yet. And for the gel, the huge question is, how long does it last? If you have to replace it every few weeks, that really changes the math on cost and convenience. And that really brings us to the most important point of all of this. Listen, neither of these inventions is going to magically replace those giant city-sized water plants. That's not the point. Their real power lies in being small, adaptable, and a totally different way of thinking about the problem.
The real magic here is for specific situations. I want you to picture a town hit by a hurricane, and the water supply is contaminated, or a remote village that's 100 miles from the nearest pipeline, or a family trying to live completely off-grid. For them, a portable, cheap, low-maintenance device isn't just cool tech, it's a lifeline.
This quote just nails it. It's a total shift in strategy. For decades, the answer to water problems was always go bigger. Build a massive dam, a giant plant. These technologies flip that script. They're about empowering individuals and small communities to create their own water security.
And I guess that's the final question to leave you with, isn't it? Have we been looking at this all wrong? Maybe the solution to a massive global crisis isn't another massive global solution. Maybe the future of fresh water is millions of tiny, targeted, and personalized solutions. Maybe it's not about one size fits all, but about one size fits one.